Community, welcome back to the PX4 Dev Summit. Our very last speaker of the day, Yin Galloway. He's going to be joining us from Prince Edward Island, Canada. He's a drone program lead at NXP. NXP is a Drone Code Gold member. The NXP mobile robotics team looks across the breadth of semiconductor products from all the NXP business lines. This includes automotive, industrial, medical, RF sensors, and wireless semiconductors. The team prepares the reference designs for FMU, CAN, two-wire, Ethernet, security, and companion computers. HoverGames is our flagship program, which provides a complete open source hardware and software design and interesting virtual challenges to get people started in development in drones and rovers. Community, please welcome Yin Galloway.
Hi, everyone. I'm here from Prince Edward Island, as you can see my background. Let me just share my screen. And is that sharing well, Ramon? All right. There we go. All right. So for those of you who haven't seen, there's been a few of my colleagues earlier that mentioned about NXP Semiconductors. We're a global semiconductor company. And one of our focus areas is in automotive. We're a leader in the automotive industry, but of course, industrial, mobile, smart home, smart city, our parts tend to get used in high reliability or long life parts, medical equipment, those sorts of things. The mobile robotics team is a small team. It started as a small drone team, and we were lucky enough to be able to focus on that. And I identified PX4 early on as the software we wanted to focus on because of its applicability and ability to be commercialized as well. We've since expanded a little bit to become a mobile robotics team. We've adapted some things like our NXP Cup car to be able to use our flight controllers and things like that. PX4-based components on vehicles. We've also done experimental VTOL aircraft and delivery vehicles. But really what as Ramon said in the introduction, we really look across the entire spectrum of components from NXP and to see what is applicable in the drone space. And in particular, you know, what we know is the area of most interest or most concern that where we can help is with automotive functional safety parts. And that means ISO 26262 and ASIL, which is an automotive safety level part that include things like onboard diagnostics and error correcting memory, and really taking these, you know, what is a mature, let's say, came up from the hobby drone industry and making it more mature and suitable for things like BVLOS, like Chris was just talking about. One of the important things to note is we don't build drones. We only build reference designs. Now, we do sell a drone kit, but I'll talk about that later. But you know, we're not in the business of making these kits. We're in the business of selling semiconductors, and everything we're doing here is to help others work with our components and get a jump start in solutions for this space. To give you an idea of automotive grade components, just to give you sort of a block diagram feel for the types of things we're talking about. This is an S32S. It's a safety-based component that's meant for things like automotive drivetrain. And you can see right off, it's quite a complex part. It's got 8 cores. There's 4 lockstep cores. So each of those has a backup. Over on the system block, you can see things like built-in self-test. And these are the sorts of things that make automotive parts automotive. They're built very carefully. The construction of the semiconductor is quite a bit different than, say, a cell phone type of part. This particular part has lots and lots of memory. And I'm not going to go over the part. I'm just saying in general, this is what you can expect from an automotive grade component. And we're working to enable those. And particularly the drone team or the mobile robotics team is able to be the bridge and help manage the challenges of using a part like this in a non-automotive industry. You know, normally these are millions and millions of pieces that get used, and they're made by they're being worked on by automotive vendors, and we were able to make the bridge to much smaller, of course, drone solutions. One of the first things we did as a mobile robotics team was build a flight controller, and this is a pretty generic looking flight controller. It's got got our PX4 connectors, and it's not a particularly small form factor. It's sort of same as a regular Pixhawk. It's based on an FMU V4 design, but we did add our own twist on a few components, particularly, of course, CAN, and future parts we have CAN FD included. But the first one is quite a bit different, is the TJA 1100. It's a 2R automotive Ethernet, and that allows you to have an Ethernet connection with just 2 unshielded twisted pair wires. Very well suited for drones and rovers and mobile robotics applications. Another part we included that was a secure element, and this was our first part to start introducing this, and it allows you to start experimenting and developing on it. So we had a flight controller, and now we said, well, what if we're going to have a flight controller? We might as well have a drone. So we put a drone kit together, and it's a very complete and quite a decent size. It's a 500 millimeter frame. It's got nice space for additional components, and made a complete development kit. And when we had a development kit, we said, well, we should maybe have a competition. So that's when HoverGames was born, and it uses the drone development kit, and we put forward a challenge, but it's a coding competition. It's not a flying challenge or anything like that. We're trying to encourage developers to get involved in PX4 and grow the community, and get people trying new things in the context of a drone. So it is open to basically everyone anywhere. And that means engineers, coders, developers. We have students. We have just hobbyists that are interested in learning a bit more. And we've seen quite a lot of activity as a result. We give out prizes. Our first competition was called Fight Fires with Flyers. And the results were quite surprising. We had over 1,000 people following. Ended up with about 50 submissions in the end, and then we ended up also internally inside of NXP getting quite a bit of interest, and I'll talk about some of those results as well. So HoverGames is meant to be an ongoing competition as well. So in the 2019 contest, it was called Fight Fires with Flyers. The idea was to help in any way a first responder in solving or helping in fighting fires or managing fire. So you don't want to take that literally. We're not talking about dropping water, but how can a drone help in this situation? And so our first winner was got involved in machine learning, and was looking for identifying people that might be stuck in a catastrophic condition, lost in the woods, etc. And so they implemented machine learning and cooperated with the drone over Mavlink communication, and implemented machine learning with an additional companion computer. Our second place winner was interesting as well. They equipped the drone with very sort of off-the-shelf fume or chemical sensors, and they used that to determine what type of fire it was, so it would help in the response. We had a number of special awards. One of them was a Drone Coder Award, and that's where they literally created heat maps. And I particularly like this because it showed the idea of a drone, a few $100 drone, and a very inexpensive heat sensor, ending up generating pretty good results in terms of resolution and sensing capability. You can see the heat maps. There's actually 2 different teams that did something similar. But by flying a grid pattern, you were able to easily detect small coals or embers or hot spots in the ground. And so it's actually very practical that instead of having quite an expensive drone, a first responder, a fire department anywhere could have one or more of these going out and searching for hot spots. The second place, I won't go into all the detail here, but we were impressed with the quick jump to machine learning that people did. And so this had several different sensors, also very low cost devices, and built a machine learning model to detect what type of fire it was. Another unusual one and quite interesting was a lightning detection system. So by adding a lightning detector, specialized IC, with some microcontrollers, another LPC micro from NXP, and other components, you would detect lightning strikes, and then as you get a frequency of lightning strikes over a certain amount, the drone would be able to go out and inspect to see if there's a fire that needs attention or if something had happened as a result. So it was quite inspiring that there's lots of different unusual examples here. And then one of our internal participants did work with our ultra-wideband parts. We have some new ultra-wideband parts that aren't quite out to the market, but they were able to use it for the beginnings of precision landing by having anchors and doing sort of millimeter or centimeter level precision for locating drones in space. Now for the next Hover Games, I said these are ongoing challenges, it's not one-off. We were going to do a search and rescue type of fair, and of course the pandemic hit, so we thought it only appropriate, it would be a little insensitive to not to do something completely obtuse to that. So we pivoted and said let's do called Help Drones Help Others During Pandemics. And so we're looking at what interesting ways can we use drones to help other people during pandemics. And that could be, like what can we learn? There's people get isolated, there's medicines that people need, there's moving blood samples from a hospital to a test lab. There's a lot of really innovative ways, and it does build upon the first Fight Fires with Flyers, where there was a lot of technology, extending radio coverage networks, and anytime there's a pandemic or a disaster situation, sometimes there's a need for a lot of infrastructure or support for first responders and that sort of thing. And so, we're thinking, how can we help people in any way? We're quite flexible on that. It doesn't, it can be quite a narrow focus, and it can be quite deep in terms of focusing on a particular software enablement as well. So we operate the contest through Hackster.io, and so applications are running until the end of July, and the contest runs all the way up until November. In promotion for this video, we did a flight YouTube video with flight test, and that was a lot of fun. One of the things we did was we actually built a tail sitter VTOL aircraft with the normal flight test build foam board build methods. And it's completely experimental. It was a lot of fun, and we do want to work on it some more to develop it further. But the thought here was, we had an opportunity to do something interesting. Maybe there's people in the PX4 community that would appreciate a low-cost VTOL tail sitter. So that actually is now, they're making it available for sale. And the important thing is also that it attracts a large audience to PX4 development as well. This has already been seen. It's only been out for a few days, and we're up to over 120,000 people have viewed this video, which means they've all been introduced in some way to PX4. And so in HoverGames 2, we are now introducing a companion computer. It's based on an i.MX processor, an i.MX 8M Mini. And we're calling this board a NavQ. It's a little stack up of boards. It is experimental, it is new, but we're enabling things like the Vision, OpenCV, there's a camera on board, GStreamer, ROS, this will grow over time. We'll do some rapid iterations on code as we determine what people want to see on a companion computer. It is actually for people that have already been in the first Hover Games. Again, it's only a $50 adder. It's quite an amazing discount that we were able to provide on a processor board of this caliber. It's basically a stack up of 3 boards. This SOM on the far left is a system on module, a SOM that is a more or less a duplicate of our normal EVK SOMs, the evaluation kits that we make for this processor. It includes eMMC memory. It has Wi-Fi and Bluetooth. The center board breaks out the camera interface, a display interface, and an SD card for your code. And then on the far right is really what makes it a Hover Games board is all the PX4 connectors and UARTs, SPI ports, etc. so we can communicate with that as a companion computer. Has a USB-C based power input, so you get 6 to 20 volt input, and we leverage that. Also can be connected directly to the battery of the drone. We also include an HDMI adapter, so if you wanted to use it as a little mini desktop, you could, and a Google Coral camera. And I'll mention over here on this slide, we're introducing a new form factor called an i.MX Industrial Ethernet, and you can see the reason is it's quite nice and small. These are made by Hirose, and this makes it possible to have an RJ40, a small enough connector for on a drone, which is a replacement for an RJ45. So to join or find out more, these are basically the links you might want to follow. You can get to it anytime through hovergames.com. We do like to partner with other companies as well, so you can look at that and contact us there. But hovergames.com will get you to the right place, and then we do have a specific registration page. There's a user guide on Gitbooks that shows you all about how to build. It's got step-by-step guides and videos. And then we have a list of different compatible PX4 drone hardware on this page, HoverGames Drone. And we can discuss things also on the PX4 hashtag HoverGames Slack channel. Now I just want to talk about some of the new developments from the NXP Mobile Robotics team, because these developments move into the next HoverGames, and what what's coming up. Let's just jump in. So NavQ and NavQ Flow. Okay, so for the first HoverGames, we did introduce some new things. We had the opportunity to build some new hardware, and we had this little product called a Rapid IoT module. That's the blue part. And so we were able to make a adapter board for that would allow the Rapid IoT module to take these click modules. Click modules that can add lots of sensors. There's over 400 of them. And I'm sorry about that. And then we ported Mavlink to it, and so it allowed new experimentation with this. The i.MX 8M Mini that we're introducing has a lot of interesting features. It has the ones I've highlighted here. It's a quad core A53, so it's a Linux computer, companion computer, running at a 1.2 gigahertz. It has hardware encoders for video. It has one MIPI CSI camera lane, and then introduces gigabit Ethernet on board, as well as other things that are available on the chip, so USB 2.0 and PCIe, etc. This is already used in a number of other commercial drone applications. Later this year, we'll introduce an 8M Plus, and I'm quite excited about this one. The biggest claim to fame here is that we introduce a machine learning accelerator. So this is designed to accelerate neural nets and operating about 2.3 TOPS. It has, again, the quad A53 processor core. It does have a secondary M7 core that could be used. We have hardware encoders for video again. This time it does H.265 and wide dynamic range encoding. And then has a dual camera interface, which allows for, with an ISP. So it allows for things like dewarping and de-Bayer patterning and hardware. And with dual cameras, we can add things like both a front and rear camera, or a time of flight camera, and a regular camera. The other thing that's quite exciting here is the connectivity. So we've now got CAN FD on board, which of course will support UAV CAN 1 quite nicely. 2 gigabit Ethernet ports, and that's also being seen as terms of connection to payload buses and things like that. And then 2 USB 3.0, which means if you were to use this as a camera head, you've got a nice high-speed USB interface that you could use, or of course you can pipe it out over Ethernet. And lots of other features here I won't go into. The important thing to remember or look at here is these are embedded, these are edge compute devices. And the idea is, unlike some of the other processors, we have optimized this so it's typically running at 2 or 3 watts. And when our current measurements today is when it's running flat out, it's only a 5-watt device. So it means that you're you can have multiple of these on board, and you're not going to require large heat sinks to weigh down a drone. Another new focus for the mobile robotics team is to use S32K. These are some automotive microcontrollers. In some ways, I kind of think of them as pickup trucks. You know, they're not all that sexy, but they are rugged, and they're automotive grade microcontrollers. So these are M4 cores running at 100 odd megahertz. And this is what we've been using in some of our new products to give you this sort of entry automotive reliability in sensors and peripherals. And to that end, okay, so another part we've also been adding is our latest sort of flagship secure element called SE050. And we're a large supplier to many passports and credit cards and bus tokens and things like that worldwide. So these are the same sorts of components that are in those parts. It's got a huge number of different key and cryptographic tools that are associated with it. And by adding these to a drone, it allows us to include authentication of modules, of submodules, and then also be used for cryptographic key storage. So if you're trying to, let's say, give authorization to fly a drone only to the firefighter that is supposed to operate the drone, or that someone has to have a certain level of authorization before they're allowed to fly a drone in a certain way, then that could be managed through keys that are stored in a secure element. And these are used all over the place in terms of industrial authentication and commissioning of IoT devices and connecting them to different networks. One of the first products to include this is we had a presentation earlier here on the summit for UAV CAN, and we have this board, a little node, a generic UCAN board, which lets you break out UAV CAN and go to traditional interfaces like UARTs, I2C, SPI, an RC PWM, so you could have build yourself a UAV CAN connected motor controller and prototype and experiment very quickly with a small, simple, low-cost board. And these designs that we do are completely open source. Like the software is open source based on PX4, and of course the hardware designs are completely open source and available for download from us. Block diagram here, we include the secure element, which has a optional NFC interface on the right, where you could maybe tap a card or tap it to another part of the drone to allow it to join the same network. Dual CAN FD. So now we can start looking at a UAV CAN application, and then yeah, fairly straightforward. There's not a lot of interesting, complex things here, so it's very flexible. Another board that we've also included these microcontrollers and secure element on, well, actually a different secure element, is our battery management reference design. This is enabled in PX4 as well. And we also included a slightly different authentication component, so even less expensive one, often used in consumable components, but it has the ability to do things like flag. If you had an abusive condition like a severe undervoltage or severe over temperature, you might burn or set a flag in the authentication component that is permanent. You can also permanently count cycles, and with that sort of thing, under certain flight requirements, you might need to do that, and you might need to be able to prove that this particular battery pack only has so many cycles on it. And again, this completely open source reference design, and it's able to scale up to quite a high battery power current. I think over 90 amps capable. Another one is a media converter. So we said we had these 2-wire automotive Ethernet on our flight controller. In order to connect to that, you need a 2-wire automotive Ethernet converter. So we built one. This is meant to be like a little dongle, and it would allow you to connect, say, over to that companion computer, the NavQ companion computer. And again, this is applicable in all sorts of other areas as well. If you just want to try a 2-wire Ethernet, you can get 2 of them and plug 2 computers together and see how it performs. We decided to also build an automotive grade Ethernet switch. So we have a 10-port Ethernet switch automotive component. So put this down on a board, a small 50 millimeter by 70 millimeter, 75 millimeter, and with 6 of these 2-wire automotive Ethernet ports, a 100 base TX port, and an i.MX industrial at a gigabit port. So this will be used for, this will be available for anyone to use, but also, we may incorporate some of these things into future hover games. And then finally, I mentioned the precision landing. We've continued to do development on that, and we're working towards being able to land a drone to centimeter accuracy on a moving platform with our ultra wideband board. Some of these things are internal at the moment, but once we get a code developed to a certain amount, at a certain level, we'll be able to make this publicly available for the general PX4 community. And that's our sort of ecosystem. It looks a bit messy, but it's growing very quickly. There's lots of different components, both we're developing as reference designs and that third parties have used our components in, things like even ADSB RF transponders for vehicles. So they use our LDMOS RF power amplifiers. We've got third-party companies building motor control, high reliability motor control, ESCs with i.MX, RT, and S32K parts. And we'll be continuing to fill this out with other solutions that people can use as reference points. So back to HoverGames, which is what I'm talking about here. Why should I join HoverGames if I'm already working on PX4? Well, first of all, there's prizes, so that's a good thing. You can get paid, or if you win, you can make a little bit of money to support your investment in time. But it might just be the incentive you need to test or implement a new application idea. It also gets you FCC CE approved hardware. This is all approved hardware, past all the regulatory requirements, unlike some hobby level grade stuff. It is a complete kit. It includes everything but the lithium polymer battery. Radio controllers included, telemetry is included, those sorts of things. You get access to some of these new hardware features to try. You might be interested in encryption or 2-wire Ethernet or UAV CAN, and this hardware has it active and is able to test and use it right away. And then the other reason maybe you don't want to join yourself, but you might want to promote it to others in order to help grow the PX4 community. And the bigger the community is and the more people developing in the space, the better it is for everyone. So the final slide, and my colleague Peter also mentioned in his UCAN board discussion, this is how to get started. You join at Hackster.io or go to hovergames.com. It'll get you over to Hackster.io. But you fill out an application with an idea, and winning applications get a coupon to get the entire drone kit and the companion computer that includes the Coral camera, adapters, power cables, mounting brackets, USB hub, all this stuff for $300. If you happen to already have a HoverGames drone, you can get the NavQ for only $50. And if when you fill out an application, you mark PX4 Developer Summit on your application, one of you will get a chance to win a free drone kit and NavQ computer. Thank you very much.
Awesome job, Ian. Thank you. There's a few questions around how to join HoverGames.
Yeah. Am I on the right
you're
slide?
Still,
I'm still not. Okay. Yeah, how to join. Go to either www.hovergames.com or you go to this Hackster link, the direct Hackster link, which is Hackster.io contests HoverGames 2. And what you do is you basically write a little profile of what your idea is and share it, and that's the application in order to be judged if you sort of win the application round.
Awesome. And can anyone join?
Yes, anyone can join. I mean, I think there are a couple of restrictions in terms of certain countries we're not allowed to ship to, but yes, anyone can join. Students, engineers, professionals. If you're employees of NXP aren't eligible for the prizes, but we do have an internal contest that follows the same track.
Awesome. And lastly, what OS are you running on the i.MX 8 Plus?
So we're going to be making a couple of options available. Normally, our customers are deeply embedded, right? So they actually want to build a stripped down, basically, usually an open embedded kernel or something like that. So it's very focused. And so what we've been trying to put together for this is a friendly Linux of sorts. It's sort of a Debian-based Linux, and we'll have a couple of flavors of that. We do expect some challenges there, but we're making great progress.
Awesome. Thank you for your time, Ian.
All right. Thank you.
Community, welcome back. Thank you, Yin Galloway. Since day one, NXP has been doing amazing work for the PX4 community. We're really excited to have you here. Next up is our next speaker, which is me. So give me one moment while I queue up my slides, and I'll be right back. Thank you. Ta-ta-ta! Community, we're back. Thank you for sticking with us throughout the whole day. It's been an amazing 2 days. Thank you for joining us. We're really excited to have everyone. We've seen people joining us from all across the globe. How did we do? Did you like the pre-recorded sessions? Did you like the live sessions? Which was your favorite? Let us know in Slack. We're still here. We're going to be here after the stream ends, and we're still going to be at the after party. So make sure you join Slack, slack.px4.io. Go to the PX4 Dev Summit channel, and there's going to be a special invite link in there. You have to look for it. It's not easy, so you have to earn it. Thank you again to the beautiful community for being here. I want to thank the Drone Code Board for their trust and this event staff. They trusted us in delivering a great event. I want to thank all the Drone Code members for all the tremendous support throughout the year. I want to have a special thank you to all of our sponsors: Alterian, Microsoft, NXP, 96 Board, CUAV, HoloPro, Ubify, to our partners, Open Robotics, Hackster, and Innerdrone, and Demian Chan. Great work, guys. Thanks for all the support. Thanks for helping us spread the word. I want to thank our speakers, all 56 of them. You guys did amazing. Thanks for being so comprehensive and for being available for us and for the community. I know it's not easy to coordinate. I know it's a pain with time zones. We tried our best. We did great. Thank you again. I want to thank the community quickly. Thank you for being here for us. You've always been here. This event wouldn't be possible without you. This is great. I want to also thank our awesome staff. This is not the slide. So you see, this is why life is fun. Hey, here we go. Thanks, staff. I want to thank Ginger, Lawrence, Asian, Stone, Farhan, Bivu, Natalia, Javier, Gong, Guada, Hamish, Nuno, Julian, Arnaud, Ian. All of you have helped us get here. Thank you for your tremendous support. It's been really hard, but we did it. We managed. Lastly, we're going to send a post-event survey. Please help fill that out. There's going to be special prizes for those of you that help us complete it. There's going to be hardware prizes. Please check your emails. Stay tuned to that. If you're new to the PX4 community, this is the first time you have experienced open source drones, welcome. We're really excited to have you here. Please let us know how we're doing. Please let us know if there's anything else we need to do to make sure we're inclusive, we're open to everyone in this community. If you're a long-term contributor to PX4 or any of the ecosystem projects, thank you. Thank you again for all the work, all the people that are live here. They're here for you. So thanks again. Thanks for making this project so good. And without anything else, I want to say bye. I guess I don't want to say bye. Oh my God. Thank you guys. Until next time, see you in Zurich next year. All right, here we go. Bye.